Welcome to these gentle, soothing stories for sleep. I am so glad you are here tonight. Whether you find yourself preparing to drift into dreams, unwinding after a long and winding day, or simply seeking a quiet companion in the stillness of this moment, you have found a safe and peaceful place. Tonight, we will embark on a journey of the mind, a gentle thought experiment into a world both strange and profound. We will explore what might happen in the quietest and most graceful way when the planet suddenly stops spinning. Before we begin our journey into the great stillness, I would love to know where you are listening from this evening, or perhaps how your day has unfolded. Please feel free to leave a gentle thought in the comments below. Wherever you are, I hope you are feeling comfortable, relaxed, and ready to explore something truly extraordinary. And if you find these soothing scientific journeys to be a pleasant companion, please consider liking this video and subscribing to our channel. It helps other souls who are searching for this kind of peace find their way here, to this quiet corner of the world. Have you ever been on a perfectly smooth train, moving so silently and steadily through the landscape that you forget you are in motion at all? The cup of water on your table is still, the gentle light streams through the window, and your own body is at rest, lulled by the illusion of stillness. You feel the gentle hum of the journey through the soles of your feet, a subtle vibration that becomes the background music of your world. And then, without any warning, the brakes engage. It is not a violent crash, not a screech of metal, but a deep, powerful, and sudden deceleration. You feel a lurch, a powerful and undeniable force that presses you forward, and for a single, disorienting moment, you become acutely, intensely aware of the speed you had forgotten you possessed. Now, imagine that feeling, that profound and silent jolt, but expanded outwards from the core of your being to encompass everything. Imagine the train is not a train, but the entire planet Earth, and the journey it is on is its ceaseless, graceful spin through the silent theatre of space. For billions of years, it has turned, a silent and faithful dancer, completing its rotation once every 24 hours, a rhythm so deep and so constant that it has become the very foundation of what we call life, of what we call time. We live within this motion so completely that we are deaf to its music and blind to its speed. But in our story tonight, the music stops. The dance ends. The planet, in a single, silent, impossible moment, ceases to spin. The first thing you would feel is not a sound, but a force. It is the law of inertia, one of the most fundamental truths of our physical universe, expressing itself on a planetary scale. Sir Isaac Newton, in his first law of motion, told us that an object in motion stays in motion with the same speed and in the same direction unless acted upon by an external force. It is a simple and elegant truth, the universe's preference for continuity. You feel it every day in small ways. When a car stops suddenly, your body wants to continue moving forward. An apple on the dashboard, not physically connected to the car's braking system, will fly forward, continuing its journey until it meets the windshield. On our spinning planet, everything that is not welded to the bedrock, the air, the water, the buildings, the trees, and our own bodies, is a passenger. We are all like that apple on the dashboard, carried along by the momentum of our world. At the equator, the Earth's surface is moving at a staggering speed, approximately 1,670 kilometers per hour, a velocity faster than the speed of sound in air. This speed gracefully tapers as one travels towards the poles, where the motion is a gentle, pirouetting stillness. But for most of us, we are traveling at hundreds of kilometers per hour, every second of every day, completely unaware. When the planet stops, our momentum does not. We, and everything around us, would be flung eastward at the speed the Earth was just spinning. It would be a silent, instantaneous continuation of our journey. This is not an explosion. It is something more fundamental. It is a separation, a moment where the planet and its passengers suddenly part ways. The kinetic energy of this global motion, this unimaginable momentum, must go somewhere. It would be transferred into the planet's crust, creating a seismic shockwave of truly biblical proportions. Not an earthquake in one place, but an earthquake everywhere, all at once. A deep, resonant hum would travel through the very bones of the world, a vibration so powerful it would dwarf any geological event in our planet's recorded history. The solid ground beneath our feet would shudder with the strain of this sudden, impossible stillness. It is a difficult image to hold in the mind, this quiet catastrophe, for it is an event defined not by a new violence, but by the cessation of an ancient and beautiful motion. It is a profound reflection on the invisible forces that cradle our existence. We live our lives utterly dependent on a momentum we cannot feel, a cosmic inheritance from the swirling cloud of gas and dust that birthed our solar system billions of years ago. We are, in the most literal sense, children of motion, spun into being. And in this moment of stillness, we are reminded that our perceived stability is just a beautiful illusion, a graceful agreement between mass and momentum. But while the solid Earth, this great sphere of rock and iron, has been brought to a halt, the thin, gentle, and invisible veil of air we breathe has not received the message. It continues its journey, and in doing so, what becomes of the wind when it refuses to stop? Imagine the softest whisper of a breeze on a warm summer evening, a gentle caress against your skin that carries the scent of jasmine or freshly cut grass. It is the very definition of gentleness, of peace. Now, hold that sensation in your mind and allow it to grow. Imagine the whisper becoming a murmur, the murmur a roar, and the roar amplifying into the sound of 1,000 freight trains, a scream that fills not just the sky, but the entire world. This is what becomes of the air when the Earth stops turning. The atmosphere, that beautiful, thin shell of nitrogen and oxygen that we call the sky, is not rigidly attached to the planet. It is a fluid, a vast and gaseous ocean held to the world only by the patient pull of gravity. And like the water in a swirling cup that continues to spin after the cup has stopped, the atmosphere retains its colossal momentum. It continues its eastward journey at speeds of over 1,000 kilometers per hour, a wind that is no longer a wind, but a planetary-scale abrasive force. This is a scouring wind, a phenomenon so far beyond any hurricane or tornado we have ever witnessed, that it belongs to a different category of existence altogether. It is the air itself, our giver of life, becoming a great and final eraser. The science that governs this moment is the simple, elegant field of fluid dynamics. We see it in the way smoke curls from a candle, or the way cream mixes into coffee. The atmosphere is a medium that flows and eddies, responding to changes in pressure and temperature. In this scenario, however, the change is one of momentum. The entire gaseous envelope of the planet, weighing more than 5 quadrillion tons, becomes a single, coherent, supersonic wave of air moving across a stationary surface. The friction generated by this interaction would be almost unimaginable. Anything that protruded from the surface of the Earth, trees, hills, mountains, the beautiful and intricate cities we have built over centuries, would be met by a force equivalent to a continuous, unending barrage of explosions. The wind would not simply blow things over, it would obliterate them, scouring them from the surface until the planet was worn smooth. It would be a sandblaster of cosmic proportions, using dust, rock, and the debris of civilization as its abrasive medium. The sheer force would strip soil from the continents, leaving nothing but bare bedrock. The great mountain ranges, the Himalayas, the Andes, the Rockies, which have stood for millions of years against the patient erosion of normal weather, would be worn down into gentle hills in a matter of hours. But beyond the physical force, there would be another, more subtle transformation. The immense friction would generate an extraordinary amount of heat. As this superheated, supersonic wind passed over the surface, it would raise temperatures by hundreds of degrees. Organic materials would not have a chance to burn in the traditional sense, as the sheer speed of the wind would likely deny them sufficient oxygen. Instead, they would undergo a process called pyrolysis. This is a thermal decomposition of materials at elevated temperatures in an inert atmosphere. It is the process we use to create charcoal from wood. In essence, the entire biosphere, the forests, the grasslands, every living thing would be cooked and carbonized, reduced to its most basic elements by a searing, suffocating gale. The sky itself would glow, not with the light of the sun, but with the incandescent fury of friction, a planet wrapped in a self-generated firestorm. It is a terrifying image, yet there is a kind of majestic, awful beauty to it. We are witnessing the conversion of kinetic energy, the energy of motion, into thermal and mechanical energy on a scale that rewrites the very face of a world. It is a stark and powerful reminder of the duality of nature. The air, which in our world carries the seeds of dandelions, the songs of birds, and the breath of life, has here become the ultimate agent of purification, of erasure. It is a force that sweeps the slate clean, a testament to the fact that the most gentle elements of our world are tethered to the most powerful of cosmic laws. And as this maelstrom of incandescent air continues its relentless journey around the globe, another fluid, far heavier, far denser, and filled with a deeper and more ancient momentum, is only just beginning to stir. Below the screaming wind, the silent, patient oceans are starting to respond to the great stillness, and their journey will be even more profound. Have you ever carried a bucket of water, walking at a steady pace, and then stopped abruptly? You can likely picture the way the water, for a moment, seems to ignore your stillness. It continues its forward motion, sloshing up against the front side of the bucket, a liquid testament to its own inertia. It is a simple, everyday phenomenon, a small dance between a container and its contents. Now, in your mind, let that bucket grow until it is the size of the earth itself, a great, spinning vessel carved from rock and iron, and let the water within it be the vast, deep, and ancient oceans that cover more than 70% of its surface. When the planet stops, the oceans, like the water in the bucket, keep going. They are a fluid body, 1,000 times denser than the atmosphere, and they possess a momentum so colossal that the mind struggles to grasp it. Their journey does not begin with the explosive fury of the wind, but with a slow, silent, and inexorable surge, a planetary scale sloshing that will fundamentally redraw the map of the world. The initial effect would be the creation of the greatest tsunami in the history of the planet, a wave so large it would not so much break upon the continents as it would simply swallow them. The oceans, continuing their eastward motion at hundreds of kilometers per hour, would surge out of their basins. The Atlantic would pour across the eastern coasts of the Americas, and the Pacific would inundate Asia and Australia. But to picture this as a conventional wave, a towering curl of water, is to underestimate its scale. This would be a rising wall of the world's oceans, a flood of such depth and power that it would scour the continents clean not just of our civilization, but of their very soil, grinding mountains down to their roots. This initial, catastrophic surge, however, is only the first and most fleeting consequence. A deeper and more permanent change is set in motion by the disappearance of a force we never feel, the centrifugal force. The Earth's spin generates an outward force, strongest at the equator, which causes the planet to bulge slightly in the middle. The Earth is not a perfect sphere. It is an oblate spheroid, about 42 kilometers wider at the equator than it is from pole to pole. This bulge affects the oceans profoundly. The centrifugal force pulls the water away from the center of the planet, causing it to pile up at the equator. In fact, sea level at the equator is roughly 8 kilometers higher than it would be on a non-spinning Earth. When the spin vanishes, so does this force. Gravity, patient and absolute, becomes the sole architect of the ocean's shape. The colossal bulge of water at the equator, no longer supported by momentum, would begin to collapse. The water would start to migrate away from the equator and flow towards the poles, where the pull of gravity is now relatively stronger. This would not be a rapid event, but a slow and majestic rebalancing of the world's water over weeks and months. The result would be a planet utterly transformed. 2 vast polar oceans would form, drowning the Arctic and Antarctic continents under kilometers of water. Meanwhile, around the planet's midsection, the seafloor would be exposed. A new supercontinent would emerge, a continuous belt of land encircling the globe where the Atlantic, Pacific, and Indian Oceans once were. This equatorial landmass, this new Pangaea, would be a world of immense, flat plains, punctuated by the deep trenches and colossal mountain ranges that once formed the hidden geography of our ocean floor. The Mid-Atlantic Ridge would become the longest mountain chain in the world, exposed to the thin, silent air for the first time. It is a profound thought that the very shape of our world, the familiar outlines of the continents that we have memorized since childhood, are not a permanent feature. They are a temporary equilibrium, a memory of constant motion written in the language of water and rock. The existence of Italy, of Japan, of California, is predicated on the planet's ceaseless spin. In this new, still world, they are gone, returned to the great ocean, or part of a new, unfamiliar land. The water has now begun to settle in its new home, and the new land has been revealed. But the solid earth itself, the very rock beneath this new geography, is also a product of its spin. And deep within the crust, a slow, powerful adjustment is now beginning. A planetary sigh that will last for millennia. There is a feeling, at the end of a long and strenuous effort, of a deep and settling sigh. It is the body releasing its tension, the muscles relaxing, the bones settling into a state of rest. It is a gentle, involuntary exhale that signifies a return to equilibrium. The Earth, having been stopped in its cosmic tracks, is now doing the same. For 4.5 billion years, it has been in a state of dynamic tension, its shape and its very substance defined by its rotation. Now, in the silence of its new stillness, the planet begins a slow, patient, and profound sigh of its own. The rock beneath our feet, which we imagine to be the very symbol of permanence and solidity, is in fact a fluid on geological timescales. It bends, it flows, and it stretches. The same centrifugal force that created the 8-kilometer bulge in the oceans also shaped the solid body of the planet. The equatorial bulge of the Earth's crust and mantle is even more significant, measuring roughly 21 kilometers. The planet is a slightly flattened sphere, a shape it has held for eons. Without the spin, this bulge is no longer sustainable. Under the relentless and uniform pull of its own gravity, the Earth begins to relax into the most stable and energy-efficient shape possible. A more perfect sphere. This transformation is not something that would happen in an instant. It is a process of deep, slow, geological time, unfolding over millions of years. But its beginnings would be felt immediately and universally. This planetary reshaping would place an unbearable strain on the Earth's crust, or lithosphere. The crust is not a single solid shell. It is broken into massive tectonic plates that float upon the semi-molten mantle beneath. As the planet's curvature begins to change, these plates would be forced to shift, buckle, and break. The result would be a world consumed by continuous, unending earthquakes. These would not be the isolated, terrifying events we know, which last for minutes at most. This would be a constant, global tremor, a perpetual shuddering of the ground as the very foundations of the world seek a new arrangement. Fault lines would appear where there were none, and ancient dormant faults would awaken with a deep and resonant groan. Alongside this seismic activity, the planet's inner heat would find new pathways to the surface. Volcanoes would erupt not in singular, explosive bursts, but in long, slow, and continuous flows of lava. Great fissures would open in the crust, bleeding magma from the mantle, building new, dark plains of basalt across the emerging equatorial continent. This process is governed by a principle known as isostasy, which is the idea of gravitational equilibrium between the Earth's crust and mantle. It is the same principle that explains why a heavy mountain range is supported by a deep root of crustal material extending into the mantle, much like an iceberg is supported by the vast mass of ice hidden beneath the water. As the planet reshapes itself, the entire crust must undergo a process of isostatic adjustment. Some areas of the crust would be forced upwards, creating new mountain ranges that rise with an imperceptible slowness. Other regions would founder and sink, becoming deep basins in the new, still landscape. We would be witnessing the birth of a new geography, forged in the slow fire of planetary physics. It forces us to reconsider our perception of time. To us, the Earth is a finished, static stage upon which our brief lives unfold. But from the planet's perspective, it is a living, breathing body. Its surface a thin skin that is constantly shifting and changing. This great stillness, has simply accelerated the process, allowing us to witness a million years of geological change in a compressed and continuous symphony of creation and destruction. The planet is not a dead rock. It is a body, and we are simply witnessing its slow, patient, and powerful transformation into a new form. As the ground finally settles and the new oceans find their divide, the sky above has undergone its most immediate and most profound change of all. What does it mean for the life that might remain, to look up and see a sun that never, ever moves? Imagine a morning that never ends. Not the gentle golden hours of a terrestrial dawn, but a morning that stretches on for weeks, then months, becoming a season of unrelenting light. The sun, which for all of human history has been our most faithful clock, our symbol of cyclical return, now hangs motionless in the sky. It is a fixed, unblinking eye, a constant and eternal source of energy pouring down upon one half of the world. On this stilled earth, the very concept of a day has been erased. The planet no longer spins on its own axis, but it does continue its long, elliptical journey around the sun. This means that a single day, one full rotation relative to the sun, now takes an entire year. For 6 consecutive months, one hemisphere of the Earth faces the sun in an endless noon, while the other hemisphere is turned away, plunged into a night that is just as long and just as absolute. Our world, once a place of rhythmic and gentle transitions, has become a planet of 2 profound and permanent extremes. Let us take a slow journey across this new world, starting on the side that faces the sun. Here, the light is not the warm, filtered glow we know, but a harsh, brutal, and sterilizing glare. Without the relief of night, the surface temperature would climb relentlessly. The initial scouring winds and global floods would have stripped away the soil and vegetation, leaving only bare rock and vast, salt-crusted plains where the oceans used to be. Under the constant bombardment of solar radiation, this rock would bake, expand, and crack. Temperatures would rise far beyond the boiling point of water, reaching hundreds of degrees Celsius. Any remaining pockets of water would have long since boiled away, the vapor driven into the atmosphere. Over centuries, the very surface of the planet would begin to melt, the silicon in the rock turning into vast, smooth seas of glass, a planetary desert shimmering under a sky that has thinned to a deep, dark violet. It is a world scoured first by wind, then by water, and now, finally, by light. It is a place of pure, unrelenting energy, a furnace where the complex chemistry of life is impossible. Now, let us travel across the face of the earth, moving towards the edge of the light. As we go, the sun sinks lower and lower towards the horizon, its light becoming redder, softer. We are approaching the boundary, the line that separates the eternal day from the endless night. This region, known to astronomers as the Terminator or the Twilight Zone, is a band of perpetual dawn or dusk that encircles the planet. Here, the sun is always on the horizon, casting long, silent shadows that never move. The temperatures are no longer at a searing extreme, but are moderated, potentially falling into a range where liquid water could, in theory, exist. It is a world of soft, red light, a permanent sunset, and it is in this thin, fragile ribbon of twilight that the last hope for life might reside. Beyond this zone, we cross over into the great night. Here, the landscape is plunged into a darkness more profound than any we have ever experienced. Without a rotating atmosphere to scatter light, the darkness is absolute, broken only by the cold, unblinking light of the stars. The temperature here plummets, falling to levels that make our own polar winters seem mild by comparison, hundreds of degrees below zero. The thin atmosphere itself would begin to freeze, nitrogen falling as a fine, crystalline snow upon a land of black, frozen rock. The oceans of this hemisphere, now a vast polar sea, would be covered in a sheet of ice kilometers thick. A silent, sleeping world, locked in a cryogenic slumber. To live in such a world would be to lose the most fundamental rhythm of our being. Our entire biology, from the metabolic processes in our cells to the complex hormonal cycles that govern our sleep and wakefulness, is built upon the gentle, 24-hour waltz of day and night. Our psychology, our poetry, our religions, our deepest myths, all are woven with the threads of sunrise and sunset, of light and shadow. We are creatures of the dawn and the dusk. What would a human consciousness become without these anchors? Would time itself begin to dissolve, becoming a featureless expanse of either unending toil under the light or unending slumber in the dark? We would be a species unmoored from our deepest biological and cultural heritage. The Terminator Zone, this sliver of moderation between two unbearable absolutes, would be the only sanctuary. But this sanctuary is not a peaceful one. For the colossal difference in temperature between the baked day side and the frozen night side will create a new and permanent kind of weather, a war in the heavens that will tear the sky apart. There is a familiar sensation on a hot summer day when you look out across a paved road or a field of dark earth and see the air shimmering. This gentle distortion is caused by warm air, heated by the ground, rising into the cooler air above it. It is a small and beautiful example of a process called convection, the engine that drives our planet's winds and weather. Now, imagine that simple, shimmering rise of warm air amplified to a planetary scale, a process no longer gentle or small, but permanent, powerful, and eternal. This is the new weather of our stilled Earth, a global engine forged in the crucible between the endless day and the unending night. On the sun-facing side of the planet, the surface is superheated, a colossal radiator pouring thermal energy into the thin atmosphere above it. The air in contact with this searing ground becomes intensely hot, expands, and begins to rise. It doesn't just rise, it soars, climbing for kilometers into the upper atmosphere in a vast, continuous, and silent updraft that covers half the world. On the dark side, the opposite is happening. The surface, locked in a perpetual night, radiates its heat away into the cold vacuum of space. The air above it becomes unimaginably cold and dense. This heavy, frigid air sinks, hugging the frozen ground, creating a permanent dome of high pressure over the dark hemisphere. The laws of physics demand balance. The high-pressure area of cold, sinking air on the night side will naturally flow towards the low-pressure area of hot, rising air on the day side. And so, a simple and brutally powerful atmospheric machine is born. At high altitudes, the hot air that rose from the day side travels towards the dark side, where it cools, becomes heavy, and sinks. And at the surface, a relentless, powerful wind blows constantly from the cold darkness, across the twilight zone, and into the searing heat of the light. This is a global convection cell, a single, unified weather system that encircles the entire planet. In our familiar, spinning world, the weather is made complex and beautiful by the Coriolis effect. The planet's rotation deflects moving objects, including wind, causing them to curve and swirl, giving birth to the elegant spirals of cyclones and the gentle rotation of weather systems. But on a non-spinning planet, the Coriolis effect is gone. There is nothing to deflect the wind. It would blow in a perfectly straight line, a constant, ferocious gale, rushing directly from the cold pole to the hot pole. The Terminator Zone, the only potentially habitable region, would be a place of perpetual, unidirectional storms of a force that would make our most violent hurricanes seem like gentle breezes. It would be a permanent hurricane, not with a swirling eye of calm, but with a straight, unending onslaught of wind. Furthermore, this atmospheric engine would be a powerful agent of chemical separation. On the dark side, the temperatures are so low that the atmosphere itself would begin to change state. Nitrogen, which makes up 78% of our air, liquefies at negative 196 degrees Celsius and freezes at negative 210. The dark side of the Earth would be cold enough for nitrogen to fall as snow, perhaps forming great, still glaciers of solid air. The planet's atmosphere would literally freeze out and be deposited onto one side of the planet. On the hot side, the opposite would occur. Any remaining volatile compounds, like water vapor or sulfuric gases released from the tormented crust, would be baked out and kept in a gaseous state, unable to condense. The water molecule itself, under the bombardment of unfiltered solar radiation, would be split apart into its constituent hydrogen and oxygen atoms in a process called photodissociation. The light hydrogen would easily escape the planet's weakened gravity, bleeding out into space forever. The Earth would be slowly, but inexorably, losing its water and its air, which would become trapped as ice on one side or lost to space on the other. The weather we know is a complex, delicate, and beautiful dance of interacting forces, a system that creates clouds, rain, and the gentle breezes that make life possible. Here, on this still world, the weather has become a brutal, simple machine. It is an engine of extremes, perpetually trying to balance an imbalance that can never be resolved. It reflects a deep truth about the universe, that complex, life-giving systems often exist in a fragile, dynamic tension. Take away the motion, the complexity, and what is left is a simpler, more powerful, but ultimately sterile order. The very air we need to breathe is being torn apart and sorted into its component parts. But as this war of winds rages across the surface, deep within the planet's core, another vital and invisible shield is beginning to fade, leaving the world vulnerable to a threat far greater than any storm. Have you ever held a simple compass in the palm of your hand, perhaps on a quiet walk through a forest, and watched its needle tremble and then faithfully align itself with an invisible line of force? There is a subtle magic in that moment, a connection to a power that is vast, ancient, and utterly unseen. That needle is responding to the beating heart of our planet, a great magnetic field that flows from pole to pole in a graceful and protective embrace. It is a shield, a ghost, and a guide, all at once. Now, imagine the source of that planetary pulse, a colossal engine of liquid iron churning deep within the Earth's core, slowly, over thousands of years, grinding to a halt. The needle of the compass would begin to drift, to wander aimlessly, its faithful guide having fallen silent. The heart of the world would have stopped beating, and its invisible shield would begin to unravel like a threadbare cloak. This magnificent magnetic field is not a permanent feature of our planet. It is the product of motion, a direct consequence of the very spin we have brought to a halt. Deep below the crust and the mantle lies the Earth's core, a sphere of iron and nickel. The inner core is solid, a ball of metal hotter than the surface of the sun, while the outer core is a vast ocean of molten metal. As the Earth spins, the liquid in this outer core churns and flows in great, complex, spiraling currents, driven by the planet's rotation and the heat escaping from the inner core. This roiling sea of liquid iron, a moving electrical conductor, generates a powerful electric current, which in turn creates the magnetic field in a process known as the geodynamo. It is a self-sustaining and wonderfully complex engine, a cosmic ballet of heat, pressure, and motion that has operated for billions of years, wrapping our world in a protective bubble called the magnetosphere. This bubble extends for tens of thousands of kilometers into space, a silent guardian against the dangers of the cosmos. When the planet's rotation ceases, the primary force driving this dynamo is removed. The great currents in the outer core would slow, become chaotic, and eventually, over the course of many thousands of years, they would cease altogether. The magnetic field would not vanish in an instant. It would first weaken, its structure becoming unstable. The magnetic north and south poles, which already wander over time, would begin to move erratically, perhaps appearing at the equator or splitting into multiple poles across the globe. For a person standing on the surface, the most visible effect would be in the sky. The beautiful auroras, the northern and southern lights, which are normally confined to the polar regions, would begin to appear everywhere. These celestial light shows are the result of charged particles from the sun being captured and funneled down the Earth's magnetic field lines, exciting atoms in our upper atmosphere. As the field writhed and twisted in its death throes, these shimmering curtains of green, pink, and violet light would dance across all latitudes, a final, beautiful, and chaotic farewell from the planet's dying heart. The very air would crackle with static energy, the world's magnetic soul fading into a memory. This fading, however, is more than just the loss of a beautiful light show or our ability to navigate. The magnetosphere is our planet's primary defense against a constant stream of deadly radiation from the sun and from deep space. Our sun emits not just light and heat, but a continuous flow of high-energy particles. Beyond our solar system, Exploding stars and other violent cosmic events create even more energetic particles called cosmic rays. Without our magnetic shield to deflect the vast majority of these particles, they would begin to rain down upon the atmosphere and the surface. This constant bombardment would shred complex organic molecules, the building blocks of life. It would corrupt DNA, making it impossible for life as we know it to survive on the surface. The world, already scoured by wind and divided by heat, would now become sterilized by an invisible rain of cosmic radiation. We live our lives so blissfully unaware of this protection, wrapped in an invisible blanket of magnetism that has nurtured the delicate evolution of life for eons. Its fading reveals a profound truth, that our planet's hospitality is not a given. It is an active, dynamic, and fragile state of being. As our shield vanishes completely, the sun, our once steady source of life and warmth, becomes a direct and ever-present danger. Its breath, once deflected, now falls upon the earth, unchecked and unforgiving. Imagine standing in an open field, feeling a soft but constant pressure against your skin, a push without movement, a wind with no air. It is a steady, ethereal force, the kind of sensation you might encounter only in a dream. This is the sun's true breath. We are accustomed to thinking of space as a perfect vacuum, an empty void between the stars. But it is not truly empty. The sun, in its immense and constant fusion reaction, is always boiling away its own outer layers, releasing a continuous stream of charged particles, mostly electrons and protons, that flows outward in all directions. This is the solar wind, a plasma that travels at speeds of hundreds of kilometers per second, carrying with it the sun's own magnetic field. It is a constant, invisible river flowing through the solar system. For all of Earth's history, our magnetosphere has been our shield, a rock in this river that diverts the flow of the solar wind around our planet, protecting our fragile atmosphere from being eroded and stripped away. With the dynamo silent and the shield gone, the Earth now lies naked and exposed directly in the path of this relentless stream. The consequences are not immediate or violent, but rather a slow, patient, and irreversible process of planetary dissolution. When the high-energy particles of the solar wind strike the atoms and molecules in our upper atmosphere, they act like infinitesimally small billiard balls. They transfer their momentum, knocking atmospheric gases with enough force to kick them into a higher orbit, or even to eject them from the planet's gravitational pull entirely. This process is called atmospheric sputtering. It is a gentle molecule-by-molecule erosion of the sky itself. From the surface of the Earth, you would notice the sky on the day side slowly thinning over the centuries, turning from a rich blue to a pale azure, then to a deep, dark violet black, the color of space itself. The stars, once hidden by the brilliance of the day, would begin to emerge, faint at first, then clearer, until they were visible even with the sun hanging motionless in the sky. The world would be losing its breath, one particle at a time. This process would be particularly devastating for the most precious of our planet's compounds, water. In the upper atmosphere, the unfiltered ultraviolet radiation from the sun would relentlessly break down water vapor molecules, H2O, into their constituent atoms of hydrogen and oxygen. This is photodissociation. The heavier oxygen atoms might linger for a while, perhaps combining with other elements or being knocked away by the solar wind themselves. But hydrogen, the lightest of all elements, is a natural escape artist. Once freed from its bond with oxygen, it would quickly rise to the very top of the atmosphere, where even a gentle nudge from a solar wind particle would be enough to send it careening into space, lost from the Earth forever. Our planet would slowly but surely desiccate, its water, the very solvent of life, being dismantled and carried away on this solar breath. Mars is a profound and nearby example of this very fate. Scientists believe that Mars once had a thick atmosphere and liquid water on its surface, but after its internal dynamo died and its magnetic field vanished, the solar wind spent billions of years stripping its atmosphere and its water away, leaving the cold, red, and nearly airless desert we see today. There is a quiet and heartbreaking poetry to this process. A planet's life, it seems, is a constant and desperate battle to hold on to its atmosphere, to cup its precious water and air in a gravitational embrace and shield it from the erosive breath of its own star. We are witnessing Earth's slow, graceful surrender in that battle. The thin veil of gas that allowed for the miracle of consciousness, that painted our skies blue and carried the sound of laughter, is now being gently unraveled and given back to the cosmos. The world is becoming a ghost, its substance thinning until only the rock remains. With the air thinning to a near vacuum and the water vanishing into space, one must ask a quiet, desperate question. Is there any place, any possible sanctuary left in this entire world, where the stubborn flame of life could possibly endure this new, harsh, and increasingly empty reality? At the very edge of the world, where the unending day meets the eternal night, in a land of perpetual twilight, let us imagine a soft, improbable glow. It is not the harsh glare of the sun-scorched hemisphere, nor is it the absolute blackness of the frozen side. It is a gentle, deep red light emanating from the ground, a fragile warmth in a world of extremes. This is the last garden, the final sanctuary, the thin, circumnavigating ribbon of the Terminator zone, where the stubborn ghost of life might cling to existence. Here, in this narrow band of moderation, the conditions that made our world a paradise have not been entirely extinguished, but have been transformed into something strange, alien, and beautiful. The colossal winds, born from the temperature gradient, still rage, but perhaps here, where the gradient is less steep, they are not a scouring force, but a constant, life-shaping presence. And most importantly, it is here that water, the solvent of life, might still be found in its liquid form. On the vast, frozen night side, the planet's remaining water is locked away in glaciers of immense thickness. But some of these great rivers of ice, driven by their own immense weight, might slowly flow towards the warmer twilight zone. As the edge of the glacier meets the slightly warmer air, the ice would begin to sublime, turning directly into water vapor, or perhaps even melt, creating rivers that run for a short distance before boiling away on the hotter side. This precious vapor, carried by the perpetual winds, would then precipitate in the cooler parts of the twilight band, falling as a constant, gentle snow or a fine, misty rain. It is a miniature, linear water cycle, a pale echo of the complex, globe-spanning system that once nurtured our world. And in this narrow, damp, and dimly lit corridor, life would have to learn a whole new way of being. The most fundamental challenge would be energy. The process of photosynthesis, which powers nearly all life on our Earth, is a dance with the sun. In the Terminator zone, the sun is a permanent fixture on the horizon, its light weak and heavily filtered through what remains of the atmosphere. The spectrum of light would be shifted entirely towards the red and infrared. Any plant life that survived or evolved here would have to become incredibly efficient at capturing this low-energy light. Perhaps their leaves would not be green, but a deep, velvety black, designed to absorb every possible photon. They might grow low to the ground, huddling together to resist the constant wind, their roots clinging to the bare rock. This would be a dark, silent, and resilient forest, a world painted in shades of charcoal and deep crimson, glowing faintly with the captured energy of a dying star's light. The creatures that might evolve in such an ecosystem would be equally transformed. They would be creatures of the wind and the dim light, perhaps with large eyes to see in the near darkness, and low-slung bodies to navigate the gales. The only forms of life that could possibly form the foundation of such a world would be organisms analogous to our own extremophiles. These are the Earth's masters of survival, the bacteria, archaea, and fungi that thrive in conditions we would consider utterly lethal. In the boiling water of geothermal vents, the acidic pools of volcanoes, the crushing pressure of the deep sea, or the radiation-soaked confines of nuclear reactors. Here, extremophiles would be the new norm. Life would huddle around geothermal vents, drawing chemical energy from the planet's still warm heart, or it would learn to repair the constant radiation damage to its cells. But there is another, stranger reality to this existence. Because the Earth is still orbiting the Sun, the Terminator zone is not static. It is a line that slowly creeps across the planet's surface, making one full circuit every year. For life to survive, it could not be rooted in one place. It would have to become a constant, slow migration. The entire ecosystem, from the smallest microbe to the largest creature, would have to move in unison. A great, silent pilgrimage that forever follows the dawn, traveling at a few kilometers per day to stay within the narrow band of habitable temperatures. Life, in this world, is no longer a property of a place, but a process. It is a journey. It is a stubborn, beautiful, and unending dance with the laws of physics. A testament to the universe's profound tendency to create complexity and persistence in the most unlikely of corners. And for any being standing on this fragile soil, looking up, the sky itself would have become a new and wondrous spectacle. What do the heavens now look like, seen through the thin, clear air of this stilled and quieted earth? Imagine lying on your back on a clear, moonless night, far from the lights of any city. The sky above is a familiar wonder, a tapestry of stars and constellations that has greeted humanity for millennia. You can see Orion the hunter, Cassiopeia the queen, the gentle glow of the Milky Way. But there is a subtle motion to it all. As the hours pass, you can see the stars rising in the east and setting in the west, a slow and majestic procession across the heavens. This celestial motion is so fundamental to our experience that we barely think about it. But it is, of course, an illusion. The stars are not moving. We are. It is the spin of our own planet that creates this beautiful, nightly parade. Now, imagine lying on the frozen dark side of our new, still Earth. The air is almost gone, so thin that it offers no distortion, no twinkle. The stars are sharp, brilliant, and perfect points of light, etched against a blackness of absolute purity. And they do not move. They are utterly, completely, and eternally still. The constellations would hang in the exact same position, every minute of every hour of every day, for centuries. The North Star, Polaris, would no longer hang just over the North Pole, but a single star would take its place as a permanent celestial zenith for any given point in the dark hemisphere. The entire concept of the celestial sphere rotating around us would be gone. The sky would be transformed from a dynamic, changing clock into a fixed and perfect map, a painted, unmoving river of light. This profound stillness would change humanity's relationship with the cosmos. For all of our history, we have found our stories in the moving stars, the journeys of gods, the changing of seasons, the navigation of our oceans. What stories do we tell? What myths do we weave? When the heavens are frozen in a single, perfect, and unchanging tableau. It is a sky that speaks not of time and cycles, but of permanence and eternity. However, not everything in the sky would be motionless. The members of our own solar system would still be following their orbital paths. The Sun, from the perspective of the Terminator Zone, would now appear to drift with excruciating slowness along a path through the constellations, a journey that would take 1 full year to complete. This path is the ecliptic, the one we are aware of in our own world, but its motion would now be directly observable against the static backdrop of the stars. The other planets, our brothers and sisters in the solar system, would also continue their own journeys, appearing as wandering stars that slowly trace their complex, looping paths across the frozen tapestry of the night. And then there is the moon. Our faithful companion would continue its orbit around the Earth, taking approximately 27 days to cross the sky. It would rise and set, but not in a matter of hours. A moonrise would be a slow, majestic event, the lunar disk taking hours to clear the horizon, its silent journey across the sky, a patient and month-long affair. Eclipses, both solar and lunar, would be transformed from fleeting, minutes-long spectacles into grand, slow-motion events. A total solar eclipse in the Terminator Zone could last for hours, a gradual and beautiful occultation of the distant sun by the passing moon. This new sky would also present a new reality for navigation. You could no longer find your way by observing the motion of the stars. Instead, you would navigate by their fixed positions. A certain constellation would forever hang above a specific region of the planet. To travel from one place to another would be to watch, with infinite slowness, as one set of constellations sank below the horizon behind you, while another rose before you. It would be a world of absolute celestial certainty. We have always looked to the heavens for a sense of wonder and perspective, a reminder of the vastness that lies beyond our own small world. This new, still sky offers a different kind of wonder. It is the wonder of perfection, of stillness, of a grand and intricate design laid bare for all to see. It is a universe that has held its breath. But while the stars above are now fixed in their silent watch, the moon continues its faithful, patient journey. And its relationship with the stilled earth, once a gentle give and take of energy, has now become something fundamentally and powerfully different. Think of the gentle rhythmic pulse of the tide on a quiet beach. The water advances and retreats in a slow, patient, and eternal breath, a soft sigh that is as old as the oceans themselves. This beautiful and constant motion is the signature of the moon's gravity, a tangible connection between our world and its celestial companion. The tide is the moon's gentle pull, made visible in the water. Now, imagine that pull is no longer a rhythm, no longer a soft rise and fall, but a constant, relentless, and unyielding strain on a single part of the world. The moon, in its silent, orbital journey, continues to exert its influence, but on a planet that no longer turns to meet it. The gentle dance has become a static embrace, a gravitational lock that will once again begin to sculpt the planet's future. The force that creates the tides is a subtle and beautiful one. The moon's gravity does not pull on the Earth uniformly. It pulls more strongly on the side of the Earth that is nearest to it, and more weakly on the side that is farthest away. This difference in gravitational pull across the planet creates what are known as tidal forces, which have the effect of stretching the Earth ever so slightly along the line, connecting it to the moon. Our planet's water, being a fluid, responds most dramatically to this stretching, creating two bulges, one on the side facing the moon and another on the opposite side. On our spinning Earth, the continents rotate through these two bulges each day, giving us the familiar rhythm of two high tides and two low tides. But on a stilled Earth, these bulges would become permanent features. The part of the planet facing the moon would have a permanent high tide, a vast, motionless bulge of water held captive. The same would be true on the far side of the world. The oceans would be locked into a new, static shape, an ellipse dictated by the silent presence of the moon in the sky. This tidal force, this patient gravitational stretching, is in fact the very process that has governed the length of our day for billions of years. The Earth has not always had a 24-hour day. In its youth, it spun much faster, with days that may have been only 6 hours long. The moon, which was much closer then, raised enormous tides on this rapidly spinning planet. The friction between the moving tidal bulges and the rotating seafloor acted as a brake, a constant and gentle drag that has been slowing the Earth's rotation ever since, gradually lengthening our days. Our sudden, artificial stopping of the Earth is merely a catastrophic acceleration of this natural, graceful process of slowing down. We have simply arrived at the end of a journey that was always meant to take eons. But here, in this stillness, the story takes an unexpected turn. The universe is never truly static. In this apparent state of rest, the seeds of a new motion are already being sown. The moon continues to orbit the stationary Earth, and its gravity continues to pull on that permanent tidal bulge of rock and water. Because the moon is moving in its orbit, its pull on the bulge is not perfectly centered. It exerts a slight, continuous tug, a force known as a torque. This torque, infinitesimally small, but applied relentlessly over immense spans of time, would begin to do something incredible. It would start to spin the Earth again. It would be a process of unimaginable slowness. Over millions and then billions of years, the moon's patient hand would pull the Earth back into motion. But it would be a different motion, a new dance. The Earth would slowly spin up until its rotation perfectly matched the moon's orbital period of 27 days. At this point, the Earth would become tidally locked to the moon, just as the moon is already tidally locked to the Earth, forever presenting the same face to its companion. The stillness was not an end, but merely a pause, a quiet interlude in a gravitational conversation that spans the life of the solar system. It is a profound meditation on the nature of time and motion, a reminder that even in the deepest silence, the universe is always whispering of future change. This silent, gravitational reshaping of the planet has another, more intimate consequence. What happens to the rhythm of our own bodies, the delicate clocks within our cells, when the great clock of the planet has been broken? There is a strange and familiar disorientation that comes with long-distance travel, a feeling we call jet lag. Your body arrives in a new place, but your internal sense of time is still tethered to the home you left behind. The sun is high in the sky, but your mind is convinced it is the middle of the night. It is a gentle, temporary confusion, a brief period where your inner world is out of sync with the outer world. Now, imagine a jet lag that never ends. Imagine that the external clock, the rising and setting of the sun, has been completely removed, leaving your internal clock to drift in a timeless void. This is the subtle, psychological reality for any complex life that might survive on a world without a day. It is an unmooring from the most fundamental rhythm of existence. Deep within our DNA, woven into the very fabric of our cells, is an ancient and remarkable mechanism, the circadian clock. Nearly all life on Earth, from the humblest algae to the most complex mammals, possesses an internal, biological clock that is naturally tuned to a cycle of approximately 24 hours. This is not a learned behavior. It is a profound biological inheritance, a genetic memory of the planet's spin. This clock governs the ebb and flow of our lives. It tells us when to feel sleepy and when to feel alert. It controls the release of hormones, the regulation of body temperature, and the rhythm of our metabolism. It is the silent conductor of our body's complex orchestra. Under normal circumstances, this internal clock is reset, or entrained, every single day by the light of the rising sun. The morning light enters our eyes and sends a signal to a tiny region in our brain called the suprachiasmatic nucleus, the master pacemaker of our body, telling it that a new day has begun. This daily synchronization keeps our internal world perfectly aligned with the external world. On a stilled Earth, this daily reset would be gone. For those living in the perpetual twilight of the Terminator zone, the quality of light would never change. For those on the day side, or the night side, there would be no cycle at all. Our internal clocks, which are not perfectly precise, would begin to drift. A clock that runs slightly faster than 24 hours might complete its cycle in 23.5 hours, while a slower one might take 25. Without the sun to correct this drift, each person's sense of a day would become their own. Our internal rhythms would become completely desynchronized from each other, and from any shared external reality. This would lead to profound psychological effects. Scientific studies involving volunteers living in deep caves for months, completely isolated from all external time cues, have shown us what happens. People's sleep-wake cycles begin to drift erratically. Their sense of time becomes distorted, with hours feeling like minutes and days blending into one another. It can lead to confusion, depression, and a deep sense of psychological isolation. Time, without its celestial anchors, begins to dissolve, becoming a calm, featureless, and eternal ocean. We do not just live on the earth, we are living with it, in a deep and resonant sympathy. Our bodies are not separate from the planet. They are an expression of its history and its rhythms. Every cell within us contains a ghost of its spin, a memory of a dance that has now ended. To be alive in this new world would be to carry within you the echo of a song that is no longer playing, a faint and persistent rhythm that no longer matches the silence of the world outside. It is a quiet and profound form of homelessness, the feeling of being a stranger in your own body, on your own planet. As our internal world loses its temporal anchor and begins to drift, the external world continues its slow, inexorable transformation. What becomes of the very elements, the chemical makeup of our atmosphere and oceans, in this new and permanent state of radical extremes? On a cold winter morning, there is a quiet beauty in the frost that forms on a window pane, the way the invisible moisture in the air transforms into delicate, crystalline patterns. And on a summer afternoon, there is a mesmerizing quality to the shimmering heat that rises from a dark road, a visible dance of thermal energy. These are two simple, everyday transformations, two expressions of the laws of chemistry and physics. Now, imagine a world that is permanently and completely divided between these two states. a planet with a soul of fire on one side and a soul of ice on the other. This is the new chemical reality of our stilled Earth. It has become a colossal laboratory, a planetary-scale crucible where the very elements are being sorted, separated, and transformed by the brutal and simple logic of heat and cold. Let us travel to the dark side, the hemisphere of unending night. Here, the temperature has plummeted to a staggering 200 degrees below 0 Celsius. A cold so profound that it begins to rewrite the rules of what it means to be a gas. Our atmosphere is a mixture of gases, each with its own unique personality, its own freezing and boiling point. Nitrogen, which makes up 78% of our air, transitions from a gas to a liquid at negative 196 degrees Celsius. On the dark side of the Earth, it would be cold enough for the nitrogen in the air to condense, to rain down from the black sky and form great, still oceans of liquid nitrogen. Where the temperature dropped even lower, this nitrogen would freeze solid, creating vast, translucent glaciers of solid air. Carbon dioxide, though a smaller component of our atmosphere, would have long since frozen, blanketing the landscape in a fine layer of dry ice. The dark side of the planet would have effectively filtered the sky, capturing and freezing the majority of its atmospheric gases, leaving behind only the lighter elements like helium and a trace of hydrogen, which have much lower freezing points. It is a world of breathtaking, alien chemistry, a silent landscape sculpted from frozen air. Now, let us journey to the other extreme, the hemisphere of the unmoving sun. Here, the relentless heat creates an entirely different chemical environment. The surface, baked for centuries, would release its volatile compounds into the thin, hot air. Sulfur, which is abundant in the Earth's crust, would be cooked out of the rocks, reacting with the scarce traces of oxygen to form sulfur dioxide. This gas, along with others released by the continuous volcanic activity, would create a hazy, toxic, and corrosive atmosphere. It would not be a sky of blue, but a permanent, sickly veil of yellow and orange. The planet, in essence, has become a massive chemical separator, a process of planetary distillation. The volatile compounds, those that easily turn to gas, are driven off the hot side by the sun's immense energy. These gases are then carried by the high-altitude winds towards the dark side, where they encounter the profound cold and freeze, falling out of the atmosphere and being permanently deposited as ice and snow. The planet is slowly sorting itself, its complex, mixed, and dynamic chemistry giving way to a simple, polarized, and static state. And what of the twilight zone, that thin, hopeful band between the fire and the ice? It would be a place of violent and strange chemical reactions. The sulfurous gases from the hot side would blow into this region, mixing with the water vapor sublimating from the great glaciers of the cold side. The result would be a perpetual corrosive rain of sulfuric acid. The Terminator Zone, our last garden, would be a world perpetually drenched in acid, a challenging environment even for the most resilient extremophiles. This great chemical sorting is, in a way, a planetary expression of one of the deepest laws of the universe. The second law of thermodynamics. It speaks of entropy, the tendency for systems to move from a state of order and complexity towards a state of disorder and simplicity. Our living, spinning Earth is a wonderfully complex and ordered system. This new, still Earth, with its sorted chemicals and simplified weather, is a system that has moved towards a state of higher entropy, a kind of thermal and chemical equilibrium. The beauty of our world was in its mix, its dynamic imbalance. The stillness has allowed it to settle into a simpler, less interesting, and ultimately less living state. We have explored the physical, the chemical, and the biological fate of this world. But what of the human legacy? What happens to the millions of silent messengers, the artificial stars we flung into the heavens, that continue their journey around this changed world? Against the perfect, static backdrop of the unmoving constellations, a single point of light glides with a smooth and silent grace. It is not a planet on its slow, wandering path, nor is it a distant, burning star. It moves too quickly, too purposefully. This tiny, travelling star is a memory of us. It is a satellite, one of thousands of artificial moons we built and launched into the heavens, a testament to a curious and restless species that once lived on the spinning world below. Now, they orbit a silent planet, their intricate electronics still following their programming, their antennas still broadcasting signals to a world that has gone deaf. They are the lonely echoes of humanity, trapped in the cold, clear amber of space. From the privileged vantage point of orbit, we can watch this new Earth in its entirety. We see the brilliant, sun-scorched hemisphere and the absolute darkness of the frozen one. We see the thin, cloudy ribbon of the Terminator Zone, where the planet's last storms rage. And circling above it all is this halo of human creation. The International Space Station, now a ghost ship, continues its relentless journey, completing an orbit every 90 minutes. Its solar panels still track the unmoving sun, its systems still functioning, but its halls are silent and empty. The constellation of GPS satellites still faithfully broadcasts the precise atomic time, a time that no longer has any meaning on the surface below. Weather satellites still point their cameras at the planet, dutifully imaging a weather system that has become brutally simple and unchanging. They are mechanical ghosts, performing their tasks with a poignant, pointless fidelity. Their continued journey is a beautiful illustration of the laws of orbital mechanics. A satellite's orbit is a delicate balance between its immense forward velocity and the constant downward pull of a planet's gravity. It is, in essence, a state of continuous falling, but always moving fast enough to miss the ground. This balance has nothing to do with the planet's rotation. And so, even though the Earth has stopped spinning, the satellites would continue their paths, governed only by the pure and simple mathematics of gravity. However, one class of satellites would have its purpose profoundly altered. These are the geostationary satellites. We placed them in a very high orbit, about 36,000 kilometers up, and at that specific altitude, their orbital speed perfectly matches the speed of the Earth's rotation. From our perspective on the ground, they seem to hover in a fixed spot in the sky, which makes them perfect for communications and broadcasting. On a stilled Earth, their orbital speed would remain the same, but the ground beneath them would be motionless. They would no longer appear stationary. Instead, they would seem to drift across the sky, completing one full circuit every 24 hours, ghostly apparitions tracing the path of a day that no longer exists. Over time, the fate of this technological halo would vary. Satellites in low orbits would eventually have their paths decay, dragged down by the outermost wisps of the thinning atmosphere until they burned up in a final, silent streak of light. But for those in higher orbits, their lifespan would be extended for millennia. With the upper atmosphere slowly freezing out or being stripped away by the solar wind, the force of atmospheric drag would become negligible. These satellites would become some of the most enduring monuments to human civilization, outlasting any pyramid, any city, any tomb. They would be our silent, orbiting memorials, a glittering, technological sphere of influence surrounding a world that has fallen quiet. It is a profoundly melancholic and beautiful image. Our creations, born of our desire to connect, to understand, and to see beyond our horizons, now circling a world that has forgotten us, forever whispering our story to the unhearing stars. Looking down from one of these lonely orbiters, one would see a planet of two simple colors, white hot and pitch black. But what if we could see this world not in the spectrum of visible light, but in the spectrum of heat itself? What hidden, abstract beauty would the heat map of this new Earth reveal? Close your eyes for a moment and turn your face towards a source of warmth, a gentle sunbeam through a window, or the soft glow of a nearby lamp. Even with your eyes closed, you can feel it. You can sense the energy, the gentle rain of photons on your skin. This sensation, this feeling of warmth, is a form of sight. You are perceiving the world in the language of infrared radiation, a spectrum of light that is invisible to our eyes, but fundamental to the universe. Now, imagine you could open a new set of eyes that saw not in colors and shapes, but purely in the beautiful flowing gradients of heat and cold. What would our stilled planet look like through this wondrous and illuminating sense? It would be a vision of stark, simple, and breathtaking beauty, a world painted in the pure physics of energy. As we look upon this new Earth with our infrared eyes, the day side, the hemisphere that perpetually faces the sun, would be a blaze of glory. It would not be a familiar yellow, but a brilliant, searing, almost uniform white. This is because all objects with a temperature above absolute zero emit thermal radiation, a glow that is invisible to us but is the very definition of existence in the infrared spectrum. The hotter an object is, the more energy it radiates. The surface of the sun-facing side, baked to hundreds of degrees, would be glowing with an incredible intensity, a beacon of pure thermal energy. The night side, by contrast, would be a uniform and profound black. Having radiated away its warmth into the cold vacuum of space for centuries, its surface temperature would be so close to absolute zero that it would emit almost no detectable heat. It would be a perfect void, a circle of absolute cold cut out of the fabric of space. The most beautiful and complex region would be the terminator zone. Here, we would witness a magnificent, feathered gradient of colour, a soft and blended boundary between the searing white and the absolute black. We would see shades of red, orange, and yellow, a permanent sunset painted in the language of heat. We could watch the flow of energy with perfect clarity. We would see the great global winds as rivers of deep red and purple, carrying cold from the dark side into the twilight zone. We would see the heat from the day side creeping into the terminator, a glowing shoreline of orange against the cooler reds. It would be a living, breathing weather map, its patterns simplified but still profoundly beautiful. This vision reveals the three fundamental ways that heat moves through the universe, all playing out on a planetary stage. First, there is radiation, the sun's energy traveling through the vacuum of space to heat the day side, and the day side radiating that energy back out. Second, there is convection, the great atmospheric engine we have explored, the physical movement of hot and cold air. And finally, there is conduction, the slow, patient transfer of heat through the solid body of the planet itself. Even on the perfect blackness of the night side, our infrared eyes might spot tiny, glowing pinpricks of light. These would be the last vestiges of the planet's inner fire. Heat from the Earth's molten core, though no longer driving a magnetic dynamo, would still be slowly leaking out to the surface. Volcanoes, erupting in the unending darkness, would appear as brilliant points of white-hot light. Geothermal vents and hot springs would glow as soft, orange patches against the deep, frozen black. These would be the last warm places in a hemisphere of absolute cold, tiny oases of geothermal energy in a world that has forgotten the sun. To see the world in this way is to understand it on a more fundamental level. We are accustomed to a world of surfaces, of colours and textures. But beneath it all, the universe is a canvas of energy flows, a constant and intricate dance of absorption, emission, and transfer. Our eyes are tuned to only a tiny, privileged sliver of this reality. This new, simplified world, when seen in the pure light of heat, reminds us that everything we see, everything we are, is just a temporary and beautiful pattern in a great cosmic river of energy. And this flow of energy does not just dictate what the world looks like, it dictates what it sounds like. In this new reality of simplified energy, what is the sound of a planet that has lost its spin? Listen, for a moment, to the sounds of our world. Even in the quietest of places, there is a subtle music. There is the sound of wind rustling through the leaves of trees, the gentle lapping of waves on a distant shore, the soft sigh of a breeze across an open field. These are the sounds of motion. They are the acoustic signatures of our dynamic, spinning planet, the result of a complex atmosphere interacting with a varied and living surface. Now, let us transport ourselves back to our still and silent Earth, and let us listen with the same attention. What are the sounds that remain in a world where the great, familiar motions have ceased? What is the new soundscape of a planet in a state of profound and lasting stillness? Let us begin our sensory tour on the dark side, the hemisphere of absolute cold and night. Here, the silence would be more profound than anything a human has ever experienced. The atmosphere is so thin and so frigid that it has all but frozen solid. There is no wind to blow, no air to carry sound. The silence would be so complete that it would feel like a physical presence, a heavy, sound-absorbent blanket wrapped around the world. The only possible sound here would be the deep, geological groans of the planet's crust as it continues its slow, multi-million-year adjustment into a perfect sphere. These tectonic tremors would be felt more than heard, a low-frequency vibration traveling through the solid rock, the silent sigh of a planet settling into its final rest. Now, we move to the twilight zone, the band of perpetual storms. Here, there would be no silence. The air would be filled with the constant, unending roar of the global winds. But it would be a sound of immense simplicity. The complex and varied sounds of our weather, the swirl of a tornado, the gusting of a storm front, the rumble of thunder are all products of the Coriolis effect, the beautiful spinning complexity of our atmosphere. Without the planet's rotation, that complexity is gone. The wind would be a constant, unidirectional force, and its sound would be a steady, low-frequency hum, a single, unchanging chord played on a planetary scale. Imagine the sound of a great waterfall, but without variation, a pure and eternal white noise. And within this great hum, a new and stranger music might arise. As the constant winds blow over the dead, eroded husks of mountain ranges, they could create pure, flute-like tones known as aeolian tones. These are produced when a steady wind passes over a sharp object. On a planetary scale, with winds that never cease and mountain ranges that stretch for thousands of kilometers, these aeolian tones could persist for centuries, a ghostly, ethereal music played by the wind on the bones of the dead world. Finally, we arrive on the sun-scorched dayside. Here, the air is thin, but incredibly hot. The predominant sound would be the soft, constant crackle and pop of the rocks as they expand and fracture under the relentless, unending heat. It would be the sound of a world slowly being baked to pieces, a sound akin to ice cubes cracking in a glass, but on a geological scale. And the nature of sound itself would be different here. The speed of sound is dependent on the temperature and density of the medium through which it travels. In the thin, frigid air of the dark side, sound would travel much slower than we are used to, and it would be heavily muffled, unable to carry very far. In the denser, hotter air near the terminator, it might travel slightly faster. We often think of silence as an absence, a void where sound used to be. But this new world teaches us that silence is a presence in itself. It is the canvas upon which new, stranger, and simpler sounds are painted. The complex organic symphony of our spinning Earth has been replaced by the minimalist elemental music of pure physics. The deep hum of convection, the ethereal flute of the wind, and the slow crackle of thermal stress. We have now seen, heard, and felt this new, strange world. But let us take a final step back. Was our spinning Earth always the way it is now? Or is this profound stillness just another, perhaps inevitable, step in a much longer and grander cosmic story? Imagine, if you will, a younger Earth, a world in its fiery and turbulent infancy, spinning with a wild and youthful abandon. Imagine a day that was not 24 hours long, but perhaps only 10, or 6, or even fewer. The sun and moon would have raced across the sky, painting the heavens in a rapid-fire sequence of dawns and dusks. This is not a fantasy. This was the reality of our own planet's distant past. The steady, graceful, 24-hour spin that we take for granted is not a primordial constant, but a relatively recent development in the grand and dramatic history of our world. The profound stillness we have been exploring is but the artificial endpoint of a long and natural process of slowing down. A cosmic ballet that began 4.5 billion years ago in a swirling cloud of stardust. Let us journey back to the very beginning, to the birth of our solar system. A vast, cold cloud of gas and dust, disturbed perhaps by the shockwave of a nearby supernova, began to collapse under its own gravity. As this cloud collapsed, it began to spin, just as a figure skater spins faster when she pulls her arms in. This is a fundamental law of the universe, called the conservation of angular momentum. All of the slight, random motions of the initial cloud were gathered and concentrated into a single, unified rotation. At the center, the sun ignited, and in the spinning disk of material that surrounded it, tiny grains of dust stuck together, growing into pebbles, then boulders, then planetesimals, and finally, into the planets themselves. Our own Earth was born from this spinning inheritance, a molten, fiery ball, rotating at a tremendous speed. Then, in the chaotic early days of the solar system, a cataclysmic event occurred that would forever change our world and define its destiny. A protoplanet, an object roughly the size of Mars, which scientists have named Theia, collided with the young Earth. It was not a head-on impact, but a glancing blow of unimaginable power, an event that would have vaporized both bodies, turning them into a single, incandescent cloud of molten rock and gas. Over thousands of years, this material coalesced. The heavier iron from Theia's core sank into the Earth's own core, while the lighter, rocky material from the crusts and mantles of both bodies was thrown into orbit. This orbiting ring of debris eventually came together under its own gravity to form the Moon. This is the giant impact hypothesis, the leading scientific theory for our Moon's origin. This colossal impact did more than just give us our beautiful celestial companion. It profoundly altered the Earth's spin. It likely knocked our planet's axis into the 23.5-degree tilt that gives us our seasons, and it set the stage for the long, slow process of deceleration that would follow. With the newly formed Moon orbiting a rapidly spinning Earth, the process of tidal braking began. The Moon, much closer to the Earth than it is today, raised immense tides on the molten surface and in the young oceans. The friction of these massive tidal bulges, dragging against the planet's fast rotation, acted as a constant and powerful brake. Just as we explored earlier, this friction slowly bled the Earth's rotational energy away, causing its spin to slow down and its days to grow longer. In this cosmic exchange, the energy was not lost, but transferred. The rotational energy from the Earth was transferred to the Moon's orbit, causing the Moon to slowly drift further and further away from us. A process that continues to this day at a rate of about 3.8 centimeters per year. Our 24-hour day is not a fixed and eternal value. It is a fleeting moment in the Earth's long, graceful journey, from a rapid spin to an eventual stillness. We were simply born in a specific, gentle era of this cosmic ballet, a time when the day was long enough for complex life to flourish, but the spin was still strong enough to power the dynamo that protects us. The sudden stillness we have imagined is simply the final act of a play that has been running for billions of years. And as we look out from our solar system into the vast cosmos beyond, we begin to realize that our planet's ultimate fate may not be unique at all. Do we see other worlds among the stars that have already reached this quiet, static, and perhaps common destination? Imagine a strange and distant world, a planet orbiting a dim, red star. One side of this world is scorched by the star's constant glare, while the other is a hemisphere of unending ice. And on the boundary between them, in the perpetual twilight, a colossal, unmoving hurricane rages, a storm larger than any on Earth, with a single, calm eye that stares forever back at its sun. Scientists have a name for such a theoretical world, an eyeball planet. This striking and beautiful image is not just a work of science fiction. It is a very real possibility, a likely state for countless worlds throughout our galaxy. The stillness we have explored as a thought experiment on Earth is, for many planets, their natural and permanent state of being. They are the tidally locked worlds, the silent eyes of other suns. As we turn our telescopes to the stars, we have discovered thousands of planets orbiting them, a rich and varied tapestry of other solar systems. Many of these planets orbit stars that are very different from our Sun. The most common type of star in the Milky Way is not a bright yellow star like ours, but a small, cool, and long-lived red dwarf. Because these stars are so much dimmer than the Sun, a planet would have to orbit much, much closer to them to be in the habitable zone, the region where temperatures could allow for liquid water. And it is this proximity that leads to an almost inevitable fate. Just as our Moon's gravity raised tides on the Earth and slowed its spin, the immense gravity of a nearby star will raise even more powerful tides on an orbiting planet. Over time, this tidal braking will slow the planet's rotation until it reaches the most stable configuration possible, a state of tidal locking, where its period of rotation perfectly matches its period of orbit. The planet is captured, forever presenting the same face to its star, just as the moon forever presents the same face to us. Our nearest stellar neighbor, Proxima Centauri, is a red dwarf star. Orbiting it is a rocky planet called Proxima Centauri b, a world slightly more massive than Earth. It orbits so closely to its star that its year is only 11 Earth days long. At this distance, it is almost certain that Proxima Centauri b is tidally locked, one hemisphere in perpetual day, the other in perpetual night. It is a world that has lived the reality we have been gently exploring for its entire existence. The state that we have framed as a catastrophe, the endless day, the eternal night, the Terminator zone, the simplified weather, is the normal, everyday existence for what might be the most common type of rocky planet in the universe. This raises a profound and humbling question for astrobiologists. Could life exist on such a world? For a long time, it was thought that tidal locking would be a death sentence. The atmosphere would freeze out on the dark side, and any water would be boiled away on the light side. But more recent and complex models suggest there may be hope. A thick enough atmosphere could transport heat from the day side to the night side, moderating the temperatures. The Terminator zone, as we have imagined, could be a stable and habitable niche, a ring of life around the planet. This realization forces us to reconsider our place in the universe. We have always thought of our dynamic, spinning Earth, with its gentle cycle of day and night, as the perfect template for a living world. But perhaps our world is the exception, not the rule. Perhaps the universe is filled not with spinning blue marbles, but with quiet, staring eyeball planets. Their life, if it exists, huddled in a band of perpetual twilight, adapted to a reality of permanence and extremes. The journey we have taken, this exploration of a stilled Earth, has led us to an unexpected destination. We began by imagining an end, a cessation of the motion that defines our world. And we have arrived at a place that, for countless other worlds, is simply the beginning, the very foundation of their existence. We have journeyed through a hypothetical disaster and found a strange new stability. We have seen our planet's potential fate mirrored in the skies of other stars. And so, as we prepare to leave this silent world behind, let us ask the final, quiet question. What is the meaning, the gentle and profound wisdom that we can find in this great and lasting stillness? What is the most permanent thing you can think of? Perhaps it is a great mountain, its granite peaks a symbol of timeless endurance. Or perhaps it is a star, a distant point of light that has shone for billions of years. Yet, the mountain is being slowly, patiently eroded by wind and rain, and it is hurtling through space on a tectonic plate. The star is consuming its own fuel, its light a fiery testament to its own slow demise, and it is moving at hundreds of kilometers per second within its galaxy. Everything, it seems, is in a state of flux. Everything is in motion. Our universe is not a collection of static objects, but a web of dynamic processes, a grand and unfolding story of change. Our journey to a stilled Earth has been a meditation on this very truth. We have, in our imagination, removed the most fundamental motion of our world, and in doing so, we have revealed how profoundly our existence is defined not by substance, but by movement. Let us gently revisit the great transformations we have witnessed, but see them now not as a sequence of disasters, but as the pure and elegant expression of physical law. The scouring wind was not an act of malice, but simply Newton's first law of motion playing out in the medium of the air. It was a demonstration of the universe's profound commitment to the conservation of momentum. The wandering oceans, reshaping the continents, were a lesson in the interplay between gravity and centrifugal force, a rebalancing of a world that had lost a key component of its equilibrium. The slow sigh of the planet's crust, the dying of its magnetic heart, the stripping of its atmosphere, each was a consequence, a logical and unavoidable step in the planet's journey towards a new, simpler state of being. We have been watching a symphony of physics, a story written in the universal language of energy and force. This journey towards stillness and simplicity touches upon one of the deepest and most mysterious concepts in science, the arrow of time. The universe seems to have a preferred direction. Things tend to move from a state of order and complexity to a state of disorder and simplicity. a quantity that scientists call entropy. A hot cup of coffee left on a table will always cool down, its concentrated thermal energy dissipating into the surrounding room. It never spontaneously gathers the heat from the room to become hot again. Our living, spinning Earth, with its complex weather, its intricate ecosystems, and its dynamic geology, is a system of low entropy, a beautiful and temporary island of order. The stilled, sorted, and simplified world we have explored is a world that has moved towards a state of higher entropy. Its journey from a dynamic dance to a static stare is, in a way, a reflection of time's arrow playing out on a planetary scale. It represents a kind of end, not of the planet itself, but of the complex and life-giving processes that its motion once sustained. And this, perhaps, brings us to the most profound reflection of all. The very fact that we are here to ponder such questions is a miracle of this delicate balance. This is a gentle version of what some philosophers of science call the anthropic principle, the idea that the universe we observe must, by necessity, be one that is capable of producing observers. The Earth's particular rate of spin, the existence of its liquid core and magnetic field, its precise distance from the Sun, the presence of its large moon, all of these are parameters in a grand cosmic equation. If any of them were slightly different, the finely tuned conditions that allow for the existence of consciousness might never have arisen. We are the product of a specific and perhaps rare set of circumstances. We are the children of a spinning world. The profound beauty of our home was never truly in its substance, the rock, the water, the air, but in its relationships, its cycles, its intricate and spinning dance. The great stillness we have imagined has given us a precious gift, the ability to see and appreciate the profound grace and fragility of that motion. And so, our journey to this silent, frozen world ends. We leave it now, in its eternal twilight, and we begin the gentle journey home, back to our own world. What is it that we carry back with us from the quiet shores of this impossible place? Listen. Can you hear it? Beneath the sounds of your room, beneath the quiet hum of the evening, can you sense a deeper, more profound vibration? It is the quiet, steady hum of the world. It is the feeling of the ground beneath you, solid and still, yet carrying you with an effortless grace at hundreds of kilometers per hour through the silent darkness of space. It is the gentle momentum of an entire planet, a silent and faithful vessel carrying you, and all of us, towards the soft light of a new tomorrow. We have returned from our journey into stillness, and we have brought back with us a newfound sense of wonder for the simple, everyday miracle of a world in motion. Let us watch, in our mind's eye, the beginning of a new day on our own, familiar Earth. See the first, faint blush of light on the eastern horizon, the slow and magical transition from the deep indigo of night to the soft rose and gold of dawn. This simple, daily spectacle of a sunrise is a gift of our planet's spin, a rhythmic turning that has orchestrated the great cycles of life for billions of years. Feel a gentle breeze on your skin, a soft and caressing current of air. This is a child of the Coriolis effect, a breath of wind made complex and beautiful by the turning of our world, a pale and gentle cousin of the scouring gales on the planet we just left behind. Think of the rhythm of the tides, the ocean's slow and steady pulse, a sign of the gravitational conversation between the Earth and Moon, a conversation that is kept in a graceful balance by our constant rotation. Every aspect of the world we call home is a direct consequence of this beautiful, ancient, and ceaseless motion. Our journey has taught us that we live within an exquisitely interconnected system. The spin of the planet drives the dynamo in its core. The dynamo generates the magnetic field that shields us from the solar wind. The shield protects the atmosphere and the oceans. The atmosphere and oceans, stirred by the planet's rotation, create the complex weather that distributes heat and water. And in this cradle of warmth, water, and protection, life was born. Biology, geology, meteorology, they are not separate sciences. They are simply different chapters in the same grand story, the story of a spinning world. And perhaps the most beautiful and mysterious product of this long, 4.5 billion year journey is us. We are not just passengers on this planet. We are a part of it. We are the planet's way of knowing itself. Our curiosity, our ability to look up at the stars and wonder, our capacity to tell stories like this one, these are not separate from the world. They are a flowering of it. Our consciousness is the universe's way of reflecting upon its own beauty. The great stillness we have explored was not a place of horror, but a place of profound teaching. It taught us to see the unseen forces that protect us, to feel the silent momentum that carries us, and to appreciate the delicate dance of cycles that defines our lives. The stopping of the world allows us to truly, and perhaps for the first time, appreciate the profound grace of its turning. To feel the spin is to feel the heartbeat of the earth. Thank you for joining me on this gentle journey tonight. I hope it has brought you a sense of peace, of wonder, and perhaps a deep and restful calm. If you have any thoughts or feelings you would like to share, I would be so happy to read them in the comments below. And if you would like to continue exploring the beautiful mysteries of our universe in this quiet way, please consider subscribing. Until next time, may your rest be deep, and may you awaken to the gentle miracle of a new sunrise. Sleep well.